quieter. So, hi, thank you for sticking for the end of the day and this talk. My name is Irena or Irena or Irina. It depends on how you can pronounce it. All work. I am the founder and CEO of Damsky Tech. It's my own consulting company that does security, intelligence, training, research, and consulting. I'm on Twitter, and I'm also here to talk to you and to introduce you to passive DNS. So just before we begin, who here has never heard of passive DNS? Okay, we have a few hands in the air. Who has used passive DNS in the past? Okay, nice. So basically, we're going to be talking about, we'll do a very quick recap of what DNS is. We'll introduce passive DNS. We'll show a few basic queries that you can make with it, then a few ideas for research, and then we'll have a Q&A session with guest stars. So, as promised, unicorns and ponies all around. So part one, quick reminder, what is DNS? So the DNS is the domain name system, and it was invented in 1983 by Paul Mokopitres. So it's not a domain name server, so when someone says domain name DNS server, that's actually legitimate, just saying. It's mainly port 53 traffic, although sometimes you'll see it in other ports. It's mainly on UDP, but although sometimes you'll see it on TCP. But for the scope of this talk, we'll just talk about 53 UDP. Basically, a DNS resolution starts from a stub resolver on your device and goes to a recursive DNS server that goes to the root servers, asking them where your where your domain is located, and so on and so on. So instead of trying to explain this, I'll just do an example. And so we'll do my script. Sorry, I don't really see what I'm writing, so basically I'm trying to do dig plus trace on Hack.lu. So yeah, no, my script is okay. It's oh, yeah. It's not okay because I can't see what I'm writing, so sorry. Here? More? Yes. No. Well, I did not sacrifice a goat to the demo gods, so, and yeah. Is that the end? .py? No. It's an interactive presentation. No. Essay. Oh, yes. So, now it works. Wonderful. So when we're looking at this, basically what you get to see is at first you have your server asking the root servers, where should you go? It's asking where are the LU servers located, and you get a list of all the root servers that point you to the LU servers, that point you to the name servers for Hack.lu, that will give you the records for Hack.lu. That's DNS trace. It works similarly to IP trace that we all know and love. And back here. So the most common DNS records, the ones that are relevant to this talk, are the A and quadruple A records that map you from a domain to an IP address, a CNAME, which is a canonical name or a redirect, NS, the name server record, MX for mails, PTR, which will be a reverse lookup from IP to domain and instead of domain to IP, text, which is whatever you want it to be, it's a text, and RRSig is the DNSSEC signature. The only reason I'm mentioning it here is because you see it, and the clutter that you see between different servers, it's basically the DNSSEC signature. There is a whole list of different DNS records that you can look at on the Wikipedia. There are a few dozens of them. Those are the most common ones. So that's DNS. Pretty simple. We all use it. We should know how it works. Passive DNS. So it was commonly agreed upon by people that it was invented in 2004 by Florian. And it's basically a historical database of DNS resolutions. So every time that someone does a resolution on a domain name, a passive DNS sensor can record that information and store it in the database. It's collected using multiple servers or sensors on the internet, and it's collected passively. So basically, the passive DNS database does not issue its own requests. It does not issue its own queries on domains, but only records queries that someone else has already done. So if no one will access a domain, that domain will not appear in the database. Another option of creating passive DNS is basically by scraping zone files. It's not that common. It's something that's available, but almost no one does that. And it's very important to remember that since the data is collected using sensors, the location of the sensors matters. So if I have a sensor in Israel and someone else doesn't have a sensor in Israel, they will not get information from Israeli clients. So it very much differs where your database sensors are located. So when you're going to query different passive DNS databases, you'll get different passive DNS results. Makes sense. You can get passive DNS from multiple vendors, and this is a list of them. Some of them are commercial, some of them are research pro, and you can get specifically data from those different vendors. And for example, NatLab will give you data that is more related to Chinese traffic because they're a Chinese vendor and most of their data is collected there. VirusTotal builds their passive DNS database from malware traffic. So the malware samples that are uploaded to VirusTotal, when they're executed in the virtual machines, they communicate with different servers, and that data will appear in the passive DNS. So it's already a skewed passive DNS towards malware. So it's a different interest. There is also another passive DNS source that's not mentioned on this slide, since it's not that public, but there are other sources that are available. So the slides will be available later, so you'll get the links to where you can find them, buy them, or apply for access. I think that that's the basics of what passive DNS is, so let's just do a few examples. If I'm trying to understand what is the IP address for a domain, I can do that with dig and understand what the IP address the domain uses now. But if I want to know what other IP addresses were used by this domain in the past, the only way that I'll be able to do that is using passive DNS data. So if we'll look at this, and this time it's hopefully going to be a bit easier for me. My script, dig plus short on Hack.lu. Sorry. Sorry. Boom. So basically the IP address for Hack.lu is 188.65.220 and 925. That's the current IP address right now. If we want to see the address for that it used in the past, or all the addresses it used in the past, we can run We can run DNS. So the examples I'm going to be showing are using the DNSDB query and the dataset from Farsight, because I have access to that dataset. This script is available on GitHub. There are other tools that are available and are better, but this is the one that I've been using for a while, so it's easier for me to use at the moment. So our set on Hack.lu. I probably meant yes. So I did mean to do this. So when I run this query, I basically get all the records that have been recorded for Hack.lu in the past, and I see all kinds of different records. I see text records, I see name server records, I see SOA records, and so on. So if I just want to see the A records, the IP records, I'm just going to limit this to /A, and then I'm going to get the IPs. And I'll get two different IP addresses. I'm getting the IP address that ends in 217.78 that was used between 2010 and 2016. And I'm getting the address that ends in 220.25. That is the current address that has been in use since 2016. So I would have not gotten the older address without passive DNS. Simple. So if you want to get historical data, then you need passive. Another thing that you cannot do without passive DNS, or you can, but it's will require you to do it with brute force, is getting the subdomains for a specific domain. So right now, if you want to do a pen testing or an evaluation of some domain, you need to query the different databases or and get the data from passive to get it. So in passive, what I can do is basically I'm going to add at the beginning of the domain. So one more, thank you. No? No. No, it's going to work like this as well, I think. Yeah. So if I'm just going to say, please give me all the records that have something before Hack.lu, I will get a list of the different domains that were recorded in passive DNS throughout the years. Just to make it a little bit easier to see, I'm also going to do a grep -v, so to remove the comments. I'm on a new command, so I'm so sorry about the technical issues. Grep -v to remove the comments. Then I'm going to do cut to catch the first field and delimiter space, sort unique, and these are all the domains that are subdomained by Hack.lu. So usually when you do brute forcing or a dictionary analysis of a domain, you will not have stuff like hackathon or well, yeah, hackathon, because the rest of them actually makes more sense than regular websites, right? So that's something that you will need to create a passive DNS database query for. Another thing that will make is possible for you to search for in this case is if you're trying to find stuff that is your brand, but with a different TLD. So someone is trying to pretend that they are you or steal your brand or impersonate you. So I'm not going to do it on Hack.lu because I assume that there are quite a lot of websites that are hack.something. So what I'm going to do is I'm going to do this on Microsoft.something, and I'm also going to grab only the A records, and still, in this case, we're going to get a few hundred or even 1,000 domains. that are starting with the word Microsoft, and then you're getting different domains and domain endings. So specifically, I should have probably limited this for the past 24 hours, because if you don't do that, it takes quite a lot of time. So we will do that in a second. Yeah. So it's going to be a little bit faster than the original query that I started. Usually in 24 hours, there are about 7,500 different domains. 7,500 different domains that start with the word Microsoft. As you can assume, most of them are not Microsoft related. Most of them are some sort of scam that's using Microsoft as a sub-label. So we'll see it in a second once it finishes. Sorry. Internet connections are fun. Yeah, it's a big query, I'm sorry. Yeah. So, have you been enjoying the conference so far? Do you come here often? Anyhow, I'm going to show you that I have a slide for this. I did not just decide to run a query in the background, but I actually had a slide for it with the, so while this runs, we'll continue. And so some of the stuff that we can do is actually, so we can do some research. So for example, we can find malicious domains or scam domains or do some phishing analysis. And to do that, we can start again from a keyword that we will want to begin with. So it could be Bank of America or Apple ID or Microsoft as an example that we've already started with. And once you start from one of those words, you already have a data set that's interesting enough to be potentially related to phishing or some sort of malicious scam. So since this is a pretty long query, usually you want to limit it to 1 week or 1 day. And we've seen why. And one of the limitations that are also a limitation in this case is that you should probably use a joker only on the left or the right side. So you could do it on both sides, not specifically in this tool by the DNSDB query, but there are other passive DNS databases that will allow that, and it will actually be a much, much longer query than even the one that we're running right now. Because if you're running a joker on both sides, that's unindexable. So you would like to run that data and run some filtering on it, and we've got results. Amazing. So you would probably, even from here, you can see that some of the domains that we have, for example, this one over here, Microsoft ZA apps, whatever, it doesn't seem like a legitimate domain to be in the internet. Not to mention other stuff. Yeah, so Microsoft XP mode download for Windows 7 driver fix for Windows7.com. It does not sound like a legitimate website. But it might only be my perception of what is a legitimate website. So you can play with the stuff that you've grabbed from here, and you can, again, grab and filter on other things in this type of output. So for example, there are things that should never exist in domains. Again, those are my personal assumptions, so you can argue with me, but I do not believe that any domain should ever have a label that says .com-something. So if I have a domain that's, that the domain goes microsoft.com-malicious-website.something.com, it makes me queasy because it makes me feel that someone is really, really trying to make the person who's looking at that domain wonder why is he, like, that domain is there just to confuse people. There is no other reason to have a .com dash domain in any normal circumstances. So if you filter your domains on that, if you filter your domains on, for example, combinations between ASCII letters and non-ASCII letters, that's something that's usually not a common thing to happen on in domains. It's more common in domains that are in the Far East. So for example, in Japan, you'll have Japanese characters and Latin characters on the same domain name, but it's not common to have French letters within a English domain. So for example, if you have the E with the apostrophe on top or with the thingy on top inside of an eBay, it's a definite homoglyph that's there only to confuse people. So if you suddenly see a Microsoft with an O with 2 dots on top, or an I with the 2 dots on top, like the naive I, that's something that shouldn't be happening. So those things, you can, again, look for them in the passive DNS and find those types of typo squats. You can look for typo squats that are a little bit easier, stuff like VV that's used instead of a W, or an RN that's used instead of an M. So all of those things, again, they're there to confuse people, and when you look at it quickly, you might not even notice this. So on these domains, you can also try and filter on stuff like suspicious TLDs. So domains that are, FQDNs that are registered under .preview and start with Microsoft.com are usually not Microsoft.com domains. Those are domains that are, in most cases, and I've analyzed quite a few of those domains, are all malicious and are used in different scams. So just saying, highly subdomain stuff. If you have domains that have more than 4 sublabels, it just doesn't work. If you have a domain.com and then you have one subdomain under that domain, that is something that is very common. If you have 2, that's not very common already. It's not something that people use in normal life. If you have more than 5, that's like really on the malicious side. The ones that have more than 10 fall into one of 2 categories. It's either I've never seen this not to be malicious, or it's someone wrote a script and it failed. So usually if you try to, and I'm not going to do this because it's taking quite a lot of time to do the demo and the script to run it, so, but if you count the number of labels within a domain, and you only look at the ones that have more than 7 labels, for example, those are probably all of them going to be malicious. Then, again, as I said, you can grab for .com in the middle of the domain name, or you can grab for .com dash, or other TLDs and stuff like that. Suspicious TLDs like XYZ or preview or stuff like that, that are more prone to be malicious. So .com and .org are more regulated. Some of the CCTLDs, some of the top-level domains that belong to countries are relatively clean. Some are, they seem to only exist for malware, like, for example, the .cc TLD. It's actually a country code. It's a country code for the Cocos Island, and I've never seen a legitimate domain that's registered in that TLD. I know that it's me that's wrong in this case because there are legitimate domains there, but I've never seen them in any logs that come from actual users. So, yeah. So, as I said, there are a lot of different things that you can filter on those domains, and then you can get a lot of interesting information from it. Another example that you can search using passive DNS, and it will save you a lot of time. So if you're looking at malware that uses DGAs, so DGAs, domain generation algorithms, are malwares that generate a big list of, or a large list of domains on a daily basis usually, and then only one or two of those domains are actually registered by the malicious actors to communicate with the malware samples themselves. So a lot of time, those domains are changed on a daily basis. To block those domains in your DNS firewall or in your infrastructure within your organization, you'll need to reverse engineer the malware, figure out all the domains that will be created on a daily basis, and then you'll have to introduce all of those domains for today, yesterday, and tomorrow into your rules to block them. So instead of doing that, you could follow up for a few days on the domains that are actually resolved, find out what the name servers are actually used by those domains, and then you can block those name servers from being contacted by machines within your network. So that will help you, because instead of blocking hundreds and thousands of domains, you can actually block 1, 2, or maybe 4 different name servers. If you'll actually do a reverse query on a name server, you'll see that a lot of times you'll see multiple malicious DGA domains that belong to that name server after you found it from an initial DGA domain. So again, I could do this example. I'm kind of don't want to do it because it's going to take quite a lot of time, and I'm sorry, I don't want to waste all of your lives. But instead, what I'm going to do is I'm going to invite a few people who's been working on passive DNS for a long time, and we can do some questions and and see what you. Yeah, just Q&A on passive DNS. I'm sorry, this was supposed to be a more interactive presentation. Well, yeah, yeah, it was. Not always you get to tell the presenter where he needs to print stuff. So I would be really happy if Aaron, Alexander, and Paul will join me on stage. So again. You want the screen?
Yeah. You're going to hand the microphone around?
Yes, we have a microphone, and if anyone has a question, we'll be happy to. Oh, good.
Hey, look at that.
Yeah, we'll be happy to have your questions.
So since my system was used, I think I should show you sort of why it takes so long, which is that the answer is large. There's a lot to say. You generally want if you're going to get a large answer, you don't want to be on a Wi-Fi network at a conference. You want to be in a data center somewhere with fast connections. And then the thing you were mentioning about the NS pivot is interesting. So, by the way, this is DNSDBQ. This is a C program that I wrote, but have no fear, it's been audited by others. That is, in my opinion, better than the old Python script that people have used. And I have ported it to Circle. And there are some things that don't work yet. We need to talk about that, and yours. But it's open source, so I'm actually counting on you guys to be pitching in here. So what's a pivot that you would have done?
So what I would have done, the example I would have done is I would have grabbed a IP address from John Bambanak's feeds for malware and DGA malwares. So I would have grabbed a domain feed. So let's say AAKA.
AAKA? MEN?
MEN.com. That's a domain that was used by Banjori malware in the past 24 hours as a CNC server for it.
All right, let me clear the screen and run that again. Can you read this, or should I use a larger font? Is this okay? All right. So you can see in this particular tool, it doesn't try and sort. That's one of the reasons it seems faster, is that it doesn't store and forward everything you did while it sorts it. But you can see that the name servers have moved around a bit. You can also see that the .com bailiwick has one report, and the acmen.com has another report, because there are NS records above you and at the apex of your zone. They happen to be the same in this case, but they need no, they're not. Look at this. NS2 and POSCI versus NS2 and NS. So here's an example of somebody who's probably hoping that you will be confused by the fact that they didn't advertise the same name servers above and below. But this ns2.vshosting.cz is interesting. So -R is the way to get this tool to ask a question starting from the left. But if you want to ask a question starting from the right, you say -N. So it'd be ns2.vshosting.cz. And I only want to see that where it's used as a name server. And so what you get from the system is a list of all the other names that have used that name server. Now, in that particular case, it was an ISP's name server, and so you're seeing the ISP's other customers. The bad guys are onto us, it seems. They've decided that if we're going to pivot on name servers, they're going to hide in a crowd. But I did want to show you those couple of demos because I can read my screen.
If you go back to this one, then you'll see that one of the name servers that it's using is ns.a.
Okay. ns. All right, let's pivot on that one. Fairly often, if it's got its own name in the NS record, it was a bespoke name server, and will not be usable as a pivot.
Unfortunately, but a lot of times what happens in this case is that the name server that is used by the DGA is actually was used by a lot of other domain names by that DGA. And this is happening because it's actually much harder. I'm sorry about the sound. It's much harder for threat actors to change the infrastructure behind the malware. It's easy to change a domain name. It's harder to change an IP address, and it's even much harder to change the infrastructure that you're using to register the domain names or to change the name servers that you're using. So when you're trying to pivot that way, it will actually give you quite a lot of information about malicious actors. Again, the malicious actors might adapt to that technique, and they a lot of times will use name servers that are more popular, and they have a lot of different domains on them. But in many cases and in many malware families, that actually works to block the name servers that way. So, again, I have not sacrificed the goat today, so unfortunately the example we chose was not a very good one.
Thanks, Paul.
What?
So, yeah, is this working? So maybe I'll add a few things. So what Paul just showed, the tool is basically a result of some discussions that we had about harmonize, because as you saw, there are many different passive DNS servers in the world, and some are more internal, some are more publicly available. But we converged on a common output format, which is written by us, and that basically allows the tool. And yes, Paul, I still have to fix mine, sorry. But basically you can query multiple passive DNS servers, get the results, and see also from the different areas of the world that these servers cover what the view is, which is also sometimes very interesting because what we often forget is DNS is actually quite local sometimes. So let me give you a story, a brief story. When you remember when Egypt went offline, I had a question. My question was, what ripple effects will that have? Because name servers in Egyptian IP space are now, both name servers are offline. Therefore, which domains are not reachable, even though they might be hosted, let's say, in the US? So that was an interesting research question, which was answerable with that, to some extent, of course. Also, I don't know if you mentioned that, or it's more implicit. Again, the passive DNS technique is an opportunistic view of DNS. It's not the complete picture, of course. It's what's seen on the wire. But so don't assume it's a complete picture, but still it's extremely useful. And I think the very large databases here, especially looking at Paul and at Alexander, and these are very useful. So I think that's what I wanted to add here.
Yeah, and I'd also add to that a lot of times, as I mentioned earlier, when you're looking at different databases, you get different geographies and different information from the people who's under the sensors that are collecting for that specific database. But on top of that, if no one actually accessed the website, no, we will not see that. And it's a question. If I've registered a website and no one ever surfed to that website, does it exist?
So in our database, we import zone files from everywhere that allows them to be exported. But we mark those as having been seen as in zone files so that they don't appear to have been active on the wire. This is the Java example, or not Java, JavaScript, JSON. So the JSON is the native output of the server, and it gets converted by the tool. So if you're tired of running awk to tear DNS results apart, as Irena was doing, your code is going to speak JSON and will do whatever you want with it. This common output format has been in production now. We've been working on it for 3 or 4 years. There's an internet draft that has been stuck for a long time because we don't talk enough. There is
I already told them.
There is a special interest group at FIRST where perhaps at the annual meeting in Scotland we will appear and give a status report, and hopefully the status is that the RFC's been published. But this schema, this JSON schema, was originally developed by Robert Edmonds, who developed the first passive DNS database for Farsight, based on a lot of work that was done by Florian Weimer, who was mentioned earlier. But I just want to say this, it works better if you can use one tool to access all the systems that you want to access instead of saying, oh, it's that guy's, I have to use a web page and scrape it. No, don't do that. But even though that works better, don't let that tempt you to put the results in a blender. There are people out there who think that nothing is worth anything until it's been aggregated, and they want to get all the answers from all the systems and dump them into one big answer. But that will lead you astray. As a researcher, you need to know what was seen together in certain time blobs by certain groups of people. And if all you see is all the gravel in one truck instead of the rocks it came from, then you will be lost.
Yeah, maybe I would like to add something about passive DNS. So it looks like an old technology that's, existing for ages and so on. But the thing that you should consider, and we have seen that we have some provider providing passive DNS, you should design even your own collections. We have seen cases where, for example, when you collect, for example, passive DNS only from Tor exit node, for example, is giving a completely different view than from a normal use from an enterprise. So the thing that is very interesting here is passive DNS collection is something that we still not really standardized. We just started to standardize basically the output format and some of the query, but we are still missing, for example, standardizing the technology behind. So if you have more people building open source solutions or even software or services regarding passive DNS, you could build new idea. And one of the ideas that we are working on right now is maybe to build an alternative WHOIS record from the passive DNS. A lot of information is basically in the record names that contain information about who to contact, even contact point. For example, in the start of authority part, you have such kind of information. So it's full of opportunities. So even if it has been invented in like 84, whatever, it's still useful. So it's very interesting on the long term for research and security research.
And I might want to add here as well, if you decide to have a local server or a sensor in your organization, there's a really good use case for that as well, which is, for example, you have a malware domain, a C2 domain. You just want to know if somebody in your organization resolved that. You can do that in many ways, but when, in what time frame, and so all these questions can be answered. It's pretty interesting, and I think we can say talk to one of us to get going.
I think all three of us represent systems that will give you API keys if you ask. I will make sure you're not planning to make commercial use out of it, because in that case I'd like you to pay. But if you have a non-commercial intent, I believe all three of us would give you a login. Just send us email. But I think we should do some Q&A.
So, okay, thank you for your talk. For what you show, it seems pretty easy to find like malicious domains, like different regular expressions and so on. Is this actively being used like for this? And what other uses apart from these are like out there? I know that when I use it, I was checking stuff off and pivoting and stuff, but like what are the main areas apart is like actively using this technology?
Well, since I'm in sales, I'll tell you what we normally pitch. And that is, if you are processing a syslog and you have one indicator, probably the thing you most want to know is it related to other attacks? So if you pivot on that indicator and say, what does it have in common with other things, and take the indicator up to the level of an attacker fingerprint, an asset cloud that gives you the fingerprint. It doesn't tell you their name, but if you see that fingerprint again, you'll know it's the same actor. That by itself is probably the single most common use, is to actually use it in defense rather than in research.
Maybe, it's really a Swiss Army knife. So it has multiple use cases. Another one would be, for example, there's a malware domain. It was taken down, but you got a report that somebody in your network is infected. You don't have the IP address anymore because the domain is down. Now you have it. Now you can look at your net flows, whatever. You can find the client, clean up, done. Yeah.
So another one could be from an red team perspective. So when you're trying to analyze or understand a target for example, for pen testing, and you're trying to collect information or intelligence about some domain, you can, as I showed earlier, you can find the different subdomains that are available. And for pen testers, that's actually it's an asset, I'd say. So that's another use case that's very, very different from the regular blue ones. So, anything else? Anyone?
Hi. Did you try using it for DNS poisoning detection?
DNS poisoning So yes, we can do that. Basically, what happens? So another example that I haven't showed, and it's a very common use for passive DNS. But when you see for example, fast flux domains. So fast flux domains are domains that change their IP on a very, very short TTLs. And then they have a few domains or maybe few dozen domains that change their IP almost every query you make. So it could be on a TTL of 60 seconds or maybe on a TTL of 0 seconds. And then every time you query it, you'll get a different domain and then, a different IP, and the domain will move. So it's very similar to this case. If I'm seeing multiple IP addresses, I can catch I can catch a fast flux attack. But I could also see that I'm usually seeing one IP address and suddenly I'm seeing a different one. And then why is that happening? So, for example, when the traffic in Iran started, so when the Iranian government started bending the traffic and reading emails, you could have seen that in the passive DNS in sort of a way, because the IP changed on the resolutions. So.
I remember a specific case, not really poisoning, but it was registrar hijacking. I remember a case where we basically analyzed a registrar that has been compromised and their complete infrastructure were taken over by the attackers. And the only way to figure out when exactly the attack started was not using their logs, but was to figure out when the first scene of the record they modified was basically used. So it was a very interesting thing that you get timestamp that was basically used for forensic analysis.
Or, for example, you could imagine you're reversing something, you have a DGA algorithm, you find some domains in there, just check where they're resolved, where they're victims.
I have a question for you, Paul, because here, hi. We discussed yesterday with Aaron whether newly observed domains, as you noted, are part of Farsight's service or commercial services. Can they actually be observed as part of passive DNS data because of, to some extent, that crawlers at some point start also receiving the zone data? And how much would that take? How long?
So the database I've demonstrated today is what makes payroll and paid for my airplane ticket to come here, but it rests on a real-time foundation, because you have to understand that a newly observed domain is only new for a short period of time. So the database is essentially timeless. We have timestamps, but it doesn't live in the now. If you want to live in the now, you don't want to have a query response system. You want to feed. And there is a feed called newly observed delegation points. Believe it or not, there are about 3 new things sold by somebody like GoDaddy to somebody like us every second. So it's about 150 to 200,000 of them per day. And then the longer names, not that you buy from GoDaddy like example.com, but a longer name like www.example.com that you'd talk to a sysadmin and say, make that for me. We're seeing between 100 and 150 of those every second that we have not seen in the history of our database. So to do the type of research I think we should be doing on these, because most of them are crap and they're created by people who hate us and want to steal our stuff, we need to be looking at that, finding the diacritical problems, finding the alphabet changes in the IDNs, finding com dash and saying we gotta put a person on that one because that's got our name and com dash, and that's sort of double doom. That is all a real-time thing, and we have not set up any demonstrations for any of our real-time systems. We've only shown you the databases today.
But it exists.
So there's some nice metrics on that stream. I wanted to actually talk with you about that. So we should talk more, exactly. So let's talk on the stage. Okay. So I did some metrics on that and some, there's some nice, how many characters are changed, Levenstein metric, etc., on the stream, which is quite interesting. So you can actually detect quickly, let's say trademark, I don't like that example, but anyway, typos of a domain, etc. You can detect that quite easily.
I want to explain that although Aaron has his own database, he also has access to ours and to our real-time streams by virtue of, I guess, a blade or a VM or something that we've made available to him. And that is, to me, where all the cool stuff is. 3 items per second is the limit of human perception. If it's more than that, you're not going to read it. So if you leave a tail -f running on that particular service, it will mesmerize you.
Hi. Would it be possible to run an additional example for another Luxembourgish website, if it's possible?
Non-English, yes, but not with this tool. I don't know how to type well.
XN minus.
If you know the way to do it, yes. But, just. All right. What we wanted. What? Oh God. No, I'm fine. What have you got as an example? What can I look up?
Maybe police Luxembourg, police.lu.
It'll still have weird characters in it.
I have an idea. What you can do, go for example to a different tab. Go to dnstwister.report. So a dnstwister.report is a DNS twist is an algorithm that allows you to look at changes to domain names. It's on GitHub, the original code, but there is this website that you can play with. So if you put the domain, so we said police.lu. So let's see what other domains are out there for police.lu. No, it's still thinking, I think. It's
working on it.
Okay, unfortunately, that's the only one apparently, but try for example, Microsoft.com. And that's a good example because you can see the...
Luxembourg is so small that I want to find out what happens if we just do this. So we should be able to find, we've seen a bunch of SOA changes. That's stupid. Let's look for the NS records instead. So as you might imagine, this command line thing is what we all love to use, but this web thing is what the customers like. So, but there should be, mx.mx.mx. What in the hell is going on there? Okay.
Yeah, remember I said that anything that has way too many domains, it's either that should not exist or someone wrote a bad script. So that the second option.
So ideally, we should be able to see, do you have IDN subdomains in .lu? I'm just going to the DNS Twister. Back to DNS Twister. It's your slot. What do you want now?
Just do new search and do Microsoft.com.
Microsoft.com.
So in Microsoft case, it's a little bit more popular for people to try and scam it. So there are a dozen domains registered with Microsoft A, Microsoft B, or Microsoft without the I, or with addition, substitution. Bit squatting would be changing a letter. Sometimes you'll have stuff a little bit further. You'll have homoglyphs. That is what we're looking for. So for example, you have
that's kerned R and an N. That's interesting.
Yeah, but this one does not resolve, so it will not work. But if you look at the one below it, so you get stuff that's actually in not Latin, well, not English letter, not ASCII letters. So it's quite fun.
So
take the one with the accent.
Are you sure that my website is not going to do the right thing if I give it UTF-8?
You should know better.
I would be happy to see it break. It's actually doing the right thing.
It actually worked.
Yeah.
Amazing.
So I don't know how to do this in ASCII on the command line, but I know how to make the website do UTF-8. Yes, if you're doing this kind of thing, it works. But frequently you don't want that, because it's a pain in your butt. So if you go back, look at the same data without that option turned on. No, don't translate the page, you idiot. Then it will leave this raw XN stuff.
Yeah, even Chrome does not believe it to be English, so.
Well, but just the same, this is what's on the wire, but since it can be represented as UTF, some tools will let you enter it that way or display it that way.
And because of that, it will make people who do not pay a lot of attention click it.
I have another question here. So this is unrelated to DNS, but you mentioned before that as long as no request has gone to any of your servers, you do not know about the domain, right? So I have talked to a few people here at Hack.lu, which is CT logs, certificate transparency logs. Now that certificates like TLS certificates are free from Let's Encrypt, a lot of phishing sites are doing that. So you can actually, like, just by looking at the streams of new logs coming in, you can see new domains popping up before they actually have sent out any emails. So this might be something that is interesting to look at.
Yeah, you have even some passive DNS collection that are basically just resolving everything in the X509 certificate, so all the distinguished names, canonical names, and so on.
Yeah, but that is only going to catch all the ones that you've ever touched. So if you have touched one that has more than one common name, then you're going to know about it. But if you use Let's Encrypt to have one certificate per subdomain, you will never find it.
One thing I want to add here is that this is essentially trying to be quiet. That's why the word passive is in the name. We've had a number of different researchers say, oh, this newly observed domain feed is wonderful. I'm going to make a query of every name I see there every 24 hours to watch it change. And I'm thinking the bad guys are running the authority name servers, and I don't necessarily want them to know what I can see or what you can see. So, you know, passive really is a way of life. And the idea of a certificate transparency thing is strange because although it will expose a domain name, it won't tell you the content. You would have to make a query to learn it, which I won't do. And we've been told to shut the hell up, by the way.
You have. There's people queuing up to do their lightning talk, so you can find these people around. You can ask them more stuff. You can do deals in the bar, I'm sure.